Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Volume. This video will help you understand volume and find the volume of common figures. Understand volume. Let's start with a definition. A figure's volume indicates how much space it takes to fill the figure. The units of volume are expressed in terms of cubic lengths or length to the third power. To understand volume and its units, it is helpful to see how volume relates to perimeter and area. Let's take a look at perimeter. Perimeter is a one-dimensional measure. We measure perimeter with line segments, so perimeter has units of length, such as feet. For example, to find the perimeter of this figure we have right here, all we're going to do is measure all of the straight lines around this figure and add those all together. So we add the length of these line segments that go around the figure, and when we add these up, we get a total of 18 feet. So the perimeter of this figure is 18 feet, a one-dimensional measure. Now let's take a look at area. Area is a two-dimensional measure. We measure area with squares. So area has units of square length, such as square feet or feet to the second power. So if we want to know the area of this figure right here, we need to know how many squares it takes to cover up that figure. And so each one of these squares is 1 foot, and if we count them all, each one of these squares is 1 square foot. So if we count all of these squares up, we have 1 square foot, 2 square feet, 3 square feet, 4 square feet. So all together here, we have 4 square feet, a two-dimensional measure. Now let's take a look at volume. Volume is a three-dimensional measure. We measure volume with cubes. So volume has units of cubic length, such as cubic feet or feet to the third power. So if we're taking a look at this figure right here and we want to know the volume of that figure, we need to know how many cubic feet it would take to fill up that figure. And you can see we've got those drawn in there, so it's easier to see those cubes that it would take to fill up this figure. We have 1, 2, 3, 4 of these cubic feet. These little cubes that are 1 foot by 1 foot by 1 foot. So we get a total volume then of 4 cubic feet. And that is a three-dimensional measure. Find the volumes of common figures. So just like with area, to find the volume of most figures, we use formulas. And let's take a look. I have 3 formulas listed here. For a rectangular box, which looks like this, we have the following formula for the volume. We take the length times the width times the height. The next figure is a cylinder, and we have a cylinder pictured here. To find the volume of a cylinder, we take pi, which we're going to use 3.14, times the radius squared, and the radius is the radius of the circle at the base of the cylinder, radius squared, and then times the height of the cylinder. The next figure is a sphere. To find the volume of a sphere, we take 4/3 times pi times the radius cubed, and the radius is just the radius of the sphere here. So here we have some other formulas for finding the volume of some common figures. If we're taking a look at a pyramid, here's the formula that we use for finding the volume of a pyramid. We take 1/3 the length times the width times the height of the pyramid. To find the volume of a cone, we take 1/3 times pi, which we'll use 3.14 again, times the radius of the base of the cone, so we have the radius of the base of the cone here, times the height of the cone. Now let's take a look at some examples that will help you understand how to find the volume of some common figures. Example 1. A cylindrical can has a diameter of 10 centimeters and a height of 15 centimeters. What is the volume? Well, we're going to use this as our formula for the volume of a cylinder. So we're going to plug this information into this formula. So let's see. The volume of our cylindrical can. Well, pi is 3.14. Now we need to multiply this times the radius squared. Well, we need to find the radius of this can. It tells us here that the diameter of the can is 10 centimeters, which means the radius of this can is going to be 5 centimeters. So we need to take the radius 5, we're going to square that, and then finally we're going to multiply by the height, which is 15. Now, to simplify or evaluate this expression on the right, we're going to follow the order of operations, which means we are starting with this exponent. So we need to first start out with 5 to the second power. 5 to the second power is 25. So we get 25 times 15. Now the order in which I multiply these numbers is not going to change the value. So I'm going to start by multiplying the 25 and the 15 together. That'll keep me from multiplying by more than one decimal number. So on some scratch work, I'm going to do 15 times 25. So let's take a look here. I'll go 15 times 25. When I do that multiplication, I get 375. So let's write that in there. So now the volume is 3.14 times 375. And so now I need to multiply 3.14 times 375. So let's see, 3.14 times 375. When I do that multiplication, I get 1,175.5. So the volume then of this cylindrical can is going to be 1,175.5. And now we are measuring in centimeters, so we want to make sure we indicate this is a volume measure. So we have cubic centimeters, 1,175.5 cubic centimeters. Let's take a look at example 2. A cone has a radius of 2 inches and a height of 6 inches. What is its volume? Well, we're going to start with our formula here. So the volume is 1/3 times pi, which is 3.14, times the radius. In this case, the radius is 2. So we're going to have times 2 to the second power, and then finally times the height. In this case, the height is 6. So I've got all this information plugged in. Now I need to evaluate this expression on the right. And again, we're going to start with our exponent. Well, 2 to the second power is 4. So I have 1/3 times 3.14 times 4 times 6. And again, I'm going to wait almost till the end to multiply by 3.14. So let's see, I'm going to first multiply 4 and 6 together, and that's going to give me 24. So I have 1/3 times 3.14 times 24. Now let's go ahead and multiply 3.14 times 24. So we come off on some scratch work. When we do that multiplication, we get 75.36. So the volume is going to be 1/3 times 75.36. Now, taking 1/3 of something is the same as dividing something by 3. So I'm going to take this 75.36 and divide by 3. When I do that long division, I'm going to get 25.12. And so the volume of this cone is 25.12. We are measuring in inches, so we want to say that that is inches cubed. Now it's time to check your understanding of finding the volume of common figures. Pause your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 1. A pyramid-shaped steeple has a square base that is 4 feet by 4 feet. If it is 9 feet tall, what is its volume? Well, here's our formula for the volume of a pyramid. So we're just going to enter this information in there. It looks like we have a length of 4 feet, a width of 4 feet, and a height of 9 feet. So we're just going to put that information in here. So when we write our formula, it'll be 1/3. So the length was 4 feet, the width was 4 feet, and the height was 9 feet. Now I'm going to multiply all of this. The order in which we multiply here will make a difference. So I'm going to multiply these 3 factors together to start. So 4 times 4 is 16. So I'm going to then take 16 times 9. So we'll come off on some scratch work and take a look at 16 times 9. And 16 times 9 is going to give us 144. Do that multiplication. And so then we're going to have the volume is 1/3 times 144. Well, multiplying by 1/3 is the same as dividing by 3. So off in some scratch work, I'm going to divide 3 into 144. And when you do 3 into 144, you get 48. So therefore, the volume of this steeple is going to be 48 cubic feet. Question 2. A rubber band ball has a diameter of 10 meters. What is its volume? Well, notice we have a diameter of 10 meters, but in our formula here, we need the radius. So if the diameter of this rubber band ball is 10 meters, the radius then is going to be 5 meters. And that's the information I'm going to plug into this formula. So let's see, we have 4/3 times pi, which is 3.14, times, in this case, 5 is the radius, and that's going to be cubed. And so we want to do the exponent first. So we'll get 4/3 times 3.14. 5 to the third power, let's take a look at that. That's 5 times 5 times 5. When I multiply those first two 5s together, I get 25. So then I'm going to take 25 times 5, which gives me 125. So I have here times 125. Now I'm going to take 125 and multiply it by 3.14. So we're going to get 4/3 times the answer to that. Let's come off on some scratch work. We're going to take 3.14 and multiply it by 125. When we do that multiplication, we get 392.5. And so we have 392.5. And now we need to take and multiply by 4/3. So what we're going to do is we're going to take 4/3 and we are going to write 392.5 as a fraction. So that's 392.5 over 1. Now to do this multiplication, we're going to multiply 392 by 4 and then divide that by 3. And so the first thing we do is we multiply that by 4. Let's make myself some room here. So we're going to multiply by 4. We take 392.5 times 4. When we do that multiplication, we get 1570, and now we want to divide that by 3. So we're going to take 3 into 1570. When we do that division, we get 523.3 repeating. So the volume of this rubber band ball is going to be 523.3 repeating, and that is meters, so we want to write in cubic meters for our answer there. Now let's take a look at how to remember these volume formulas. Remembering the volume formulas is actually pretty easy as long as you understand how we get these formulas. And for formulas that don't end in a point where the two bases are the same, basically if the bottom of the figure, like here when we have a rectangular box, the bottom of the figure is the same as the top. Same thing over here with a cylinder. The bottom is a circle, the top is that exact same circle. When we have figures like this, the way that we come up with a formula is we just take the base area and multiply it by the height. And I'll show you what I mean here. So for the volume of the rectangular box, we're going to first look at the base area. Well, that base area is a square, or sorry, a rectangle. And when we're finding the area of a rectangle, we take length times width. And so the base area of this rectangular solid is length times width, and then we're just going to multiply that times the height. And that's how our formula. That's where we get our formula for that rectangular box. Same idea here with a cylinder. The volume of the cylinder, we're going to think the base area times the height. Well, the base of this cylinder is a circle, and the way that we find the area of a circle is pi r squared. And now we're just going to take that base area and multiply times the height. So then we multiply by h. There's our volume for the cylinder. Now if we're looking at the volume of a pyramid or a cone, it's very similar. The only difference, we're still going to take base area times height. The only difference is we're going to multiply by 1/3. So if a figure starts out with a base but ends in a point, we're going to multiply it by 1/3. Same thing here. Notice we start out with a circle, but we're ending with a point, And so that indicates that we need to multiply this base area times height times 1/3. Let's take a look at the volume of the pyramid. So we're going to multiply 1/3 times the base area. Well, the base area, again, is this is just a rectangle, so we're going to take length times width and then times height. So we just have 1/3 length times width times height. Same idea for a cone. 1/3. The base area here is a circle, and the way we find the area of a circle is pi r squared, and then we're going to multiply that times the height. So hopefully these ideas will make it easier for you to remember or memorize these formulas. Again, it's just taking the base area times the height, and then if the figure ends in a point, we take 1/3 base area times the height. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.